Alright, so this is number 3 on page 6. We're going to do the same exact thing, so let's read this. A ship sails 50 miles on bearing of 20. So this sentence right here will make my A. Sorry, I'm not creative. And 30 miles further on bearing of 80. So that's going to be my vector B. And they want us to find the resultant displacement vector as a distance and bearing of its vector. So basically it means for us to find the magnitude and direction of the vector. Alright, so let's go for it. Let's do our vector A here. And that's going to help us out with, I always like to draw it out because it helps me a whole lot more to do that than not. So I'm going to draw it out. Probably down here. Alright, so here we go. Here is my quadrant points, and I know it's bearing, so it starts 0 here. It's 50 miles on bearing of 20. That means I need to go 20 degrees clockwise, and that's going to look somewhat like it. It's going 20 degrees clockwise from here, so about here. It doesn't go that far because it's 20 degrees. And we know it's going to be 50 miles, so that is 50 miles here, and that right there is 20 degrees, which means my reference angle here, that angle right there, my angle of that would be 70 degrees to make a full 90 degrees there. So let's go for it. To get my X and Y, I'll have to do the magnitude, which is 50 miles, and cosine of the degree and magnitude times sine of 70, because that's going to give us that thing. And remember, if you wanted to drop the perpendicular line and do the right triangle trig, you could have. Okay? Now, let's go ahead and set up my vector B before I just punch this in the calculator. So that way I'm just minimizing calculator uses here. My vector B is, we're going to have it right here. Let's set that up here. So it's going to be 30 miles, so that's the distance, further on bearing of 80 degrees. So which means, here's my 0 degrees. So it's going to be clockwise 80 degrees. And let's go ahead and draw that. So it's going to be closer to there. And since from there to there is 80 degrees, we know that our reference angle that we always refer to by dropping down the perpendicular line to the x-axis is going to be 10 degrees to make that 90 degrees. So once again, to get our corner points, we'll get 10 cosine, oops, my bad. Got it mixed up. Magnitude, which is 30 cosine of 10 degrees, and 30 sine of 10 degrees. Now let's work on our resultant vector. Now once again, remember, our resultant vector is obtained by adding the first two vectors together. Since I'm not that creative, I'm going to call it resultant vector R. And we are actually going to be able to get the points fairly easy on here. Alright, so we're going to go ahead and add them together on my calculator. Make sure that it is on degree mode. So I'm going to add the x's together. So I'll do 50 cosine of 70 degrees, close the parentheses, plus, what was the other one? 30 cosine of 10 degrees. And that's going to give us 46.645. So 46.645 to the right, since it's our x corner point. Now we're going to add the y's together. So 50 sine of 70 degrees, close the parentheses, plus 30 sine of 10 degrees. will give us 52.194. 0.194. Now we got our component forms for this one. Let's go ahead and draw this out so we can find our angle and magnitude. And if some of you guys don't like to draw this out, but since we are on bearing mode, I suggest that you would, because that's going to help you to find the direction of this a lot better, especially when the problems get a little more complicated. So, excuse me. It's going to be 46.645 to the right and 52 to the height. So it's going to look somewhat like this. And you know that we usually drop the perpendicular line to the x-axis, which means my x distance right here is 46.645. And my y distance there would be 52.194. Let's do one thing at a time. Once again, you guys can use Pythagorean theorem to find, since it's a right triangle, find the hypotenuse or the distance of the vector. And I'm just going to write it out for us. So it's going to result vector is equivalent to 46.645 square root, which is a squared plus square root of a squared plus b squared, which is 52.194 squared. Let's go ahead and type that in for us. The square root of 46.645 squared plus 52.194 squared, which would be 69.999. It rounds up, so I'm just going to go ahead and put 70.000. That's how long this thing is, right? 70. Now let's go and find our theta. Now remember that when you do the theta, since you're doing SOHCAHTOA, your calculator is going to give you your reference angle. So let's go ahead and remember that. Remember, this is our vector r. So we'll do theta equal tangent inverse, because tangent is y over x. We'll do y over x. Okay. So tangent inverse, we'll do y 194 over x. That's going to give us 48.213 degrees. However, that's this angle here, right? 48.213 degrees. But you want, once again, you want your bearing starts at 0 here. So you want the counterclockwise from 0. So we'll do 90 subtract 48.213. That's going to give us 41.787 degrees. And remember, the way that I'm going to notate is theta sub r.